Alrighty, so in this video, you're going to see some different examples involving, like I said, those new vocabulary words we talked about in the previous video, inscribed in and circumscribed about. So what I'd like you to do is go ahead, try these 5 examples on your own. The first thing I would do is label your diagram with the given information, refer back to the notes, especially those 2 new theorems that we've already discussed, and see if you can come up with these answers. So go ahead, pause the video now, and then press play when you're ready to check your answers. Alrighty, so let's go through these real quickly and have you kind of check your answers. And number 1, I labeled it, we were given angle A and angle B, and then it asked us to find angles C and D. So that was just using that first theorem. We know that opposite angles, if a quadrilateral is inscribed in a circle, then opposite angles are supplementary. So for angles A and C, I just had to do 180 minus 85 to get 95 degrees. And then for angles B and D, those are opposite angles. So 180 minus 63 gave me 117. So that was how you get those 2 answers. Hopefully that was an easy one for you. In example 2, it asks us to find the measure of angle S and the measure of arc QR. So I could find the measure of angle S the same way because I know that S and Q are opposite angles. So subtract 180 minus 76, and that's how I got 104 degrees as the measure of angle S. And then notice that I highlighted here in red arc PR because arc PR is the arc that is between angle S. So it's the arc that's between that angle S here. So I know that because the vertex of angle S is on the circle, that arc would have to be double that angle measure. So double that angle measure is 208 degrees. And since I already know that arc PR is 128 degrees, I did 208 minus 128 to get whatever was left over, which ended up being 80 degrees. So that's how I got my answer for the measure of arc QR. Now this next one usually throws people off a lot, but if you really think about what a regular polygon is, our definition, it makes it real easy. So we're given that HEXAGO is a regular hexagon, and then it asks us to find the measure of 3 different arcs. Well, if it's a regular hexagon, that means all the sides and angles are congruent. So therefore, each of those arcs would also be congruent, because we know if we have congruent chords, then we have congruent arcs. So if you take 360 and you divide it by 6, you get each of those 6 arcs to be equal to 60 degrees. And then that's how I got my 3 answers for number 3. Number 4 is a little bit trickier, but it does give us that angle T is a right angle, so therefore then we know that angle R must also be a right angle since opposite angles are supplementary. Then I connected points Q and S to get this 2 right triangles. And if 2 of the sides of the right triangle are 30 and 40, then I know the third side must be 50 because that's a 3, 4, 5 triple. And then if I look at my other right triangle, I have 14 and 50. I know that's a 7, 24, 25 triple. So the missing side, QR, is equal to 48. So that was kind of just using triples to get those answers. Now I didn't quite finish number 5 because I wanted to work on that together since that's typically the most challenging one. I labeled the diagram with the givens, and since this is a parallelogram that is inscribed in a circle, we know it must be a rectangle. So that's how I know that angle I and angle K are right angles. Angle J and L are also going to be right angles. Now the reason it gives us this arc to be 120 degrees is so that we can get the measure of this angle L, which is going to be half of that arc. Since its vertex lies on the circle, it's half the arc that's in between it, so it would be 60. So this would be a 30, 60, 90 right triangle. The reason it gives us MO is because that is the radius of the circle. So now that I know the radius of the circle, I know that LJ is the diameter of that circle. So LJ is going to be equal to 20, double that radius. Now that I have that information, now all I need to do is find the 2 sides of my rectangle and then I can figure out the perimeter. So the side across from the 90 and a 30, 60, 90, that's equal to 2x. So set 20 equal to 2x. We get x is equal to 10, and that's going to go across from the 30. So both of these sides are going to be 10s. Use different color then. For the side across from the 60, I know that's going to be x root 3. So that would be equal to 10 root 3, the side across from the 60-degree angle. So to find the perimeter, I know I can add the two 10s together. So 10 plus 10, I get 20. And then I can add the 10 root 3's together to get 20 square root 3. So that would be the perimeter then of that rectangle. So hopefully you have a better idea of what it means to be circumscribed about or inscribed in. Make sure that you look over these examples again if you get stuck, and try to remember the two theorems we talked about. The first one had to do with if a quadrilateral is inscribed in a circle, then opposite angles are supplementary. You can automatically assume that just by looking at the diagram. The second theorem we talked about, if a parallelogram is inscribed in a circle, then it must be a rectangle. So keep those theorems in mind as you're working through this section